Okay, kids, let's do a calculation. You know how you pull up to a street light, red light, sitting there, mind your own business, listen to your little tunes on your radio, and another car comes alongside you. You got your windows closed. They have their windows closed, but their car is so loud that you can't even hear your own stereo. Okay, that's somebody, those really annoying people that you might have some colorful adjectives. What are they doing? What's the point? I mean, what are they doing? They trying to overcompensate for something? Who knows? But anyways, point is, so they might have a 500-watt stereo. Well, what if they only used 2 of their 500 watts? What if 500 watts, I got my 500 watts, I got a super stereo. Yeah, let's show you how much time, and how much power that you're wasting. Okay, and how much money you waste in this stereo. Let me show you. We'll do it with math. We'll prove it with physics, people. Let's say that you use dos wattados, which is 2 watts out of your 500 watts. And you're 1 meter away. 1 meter about from me to the camera away. Okay, so you're relatively close, and you're using 2 watts. Let's check where you'd be on the decibel scale. Let's calculate. That's what this equation is all about, Charlie Brown. So let's do a calculation. So how many decibels would that be? All right, well, let's say 10 times the log of I. Now remember, I is watts per square meter. Watts per area. Square meters is area. Okay, so watts, now we're using 2 watts over area. Now what area are we talking about? Like, is it a square? No. Sound, when it propagates from a source, is going in all directions, 3 dimensions. What's 3 dimensions from this one spot? That's right, sphere. So we need the area of a sphere because that's what the area is from a sound source. So we need, and we all remember the area of a sphere. Pi r squared. No, that's, no. It's the area of a circle. 4/3 pi r cubed. No, that's the volume of a sphere. Close, kind of combine those and you get 4 pi r squared. Yes, 4 pi r squared. And so 4 pi r squared is going to go on the bottom of the I. You can remember I is watts per unit of area, with the unit's going to be square meter. So watts per area, the area of a sphere is going to be that. So that's always going to go in there. Write it down. Okay. So now what else? Divide by I/O. So off to work I go, which is 1 times 10 to the negative 12. 1 times 10 to the negative 12. Okay, let's do it. Let's calculate that. It's set up for you. I'm sure you're all doing this at home, right, kids? No, you relax. You've had a tough day. I got you, okay? And I'll make that delivery of coffee and donuts or hot chocolate, whatever you like, very soon. Just you hang on. You just wait, okay? Just wait. So here we go. What you have to do when calculating, you don't go 10 times log and try to put in this thing. You'll screw it up in your calculator. Trust me, you will. Work from the right to left. I know, backwards, right? Work from right to left. Do this first and then go over here and go to the left. I'll show you what I mean. So let's take 2 and divide it by 4 pi r squared. We need a distance. How far are we from? We said a meter, right? I said a meter. 2 watts at a meter. So 1 meter will go in here. R is how far you are from the sound source. But you might, isn't that the radius? So if you're a meter, shouldn't you cut that in half to get? No. It is the radius, but the radius of the sphere. And so 1 meter is 1 meter is 1 meter is 1 meter is 1 meter all around the sphere. So R is how far you are from the sound. So that's 1 meter. Now, of course, I use 1 meter because it makes the math a lot easier, right? But if it's not a meter, you got to put, if it's 3 meters away, you put 3 in there, square 3, get 9 and multiply through. 1 is just squares 1. So 2 divided by 4 pi. So here we go. 2 divided by 4, enter, divided by, I'm going to use 3.14 for pi. 3.14, enter. Okay, I get that number there. And then, so we got 2 divided by this, got that, divided by this, 1 times 10 to the negative 12. So divided by 1, second function, exponent, negative 12, enter, boom, and now I get that value there. Okay, that's what I have for this stuff here. So I'll write that down. It's 1.59 times 10 to the 11th. So right now, decibels equals 10 times log, 1.59, I forget what I said, 1.59 times 10 to the 11th. So 1.59 times 10, run out of room there, the 11. So now go ahead. Now we take the log of this. Just hit the log button, people. You don't have to remember that logs are exponents. You don't have to remember that. All you need to do is hit the button. Okay, you can do that. I have faith in you. Hit the button. We got a log button right there. Boom, log, log. Kids love logs. Logs, log. It's Ren and Stimpy. Check it out. Pretty funny. Check out Ren and Stimpy, the log song. Don't do it. Don't do it. I'll wait. Ren and Stimpy. Ren and Stimpy. R-E-H-N and Stimpy log song. Log song. Cool. All right, you listen to it? Pretty funny, right? Yeah, kids love log. Okay, so log that. So I'm just going to hit log, second function answer of what I had above, and I get 11.2. 11.2. So then 11.2 multiplied by 10 is 112. 11.2 multiplied by 10. Okay, without the 10, we have bells. We want decibels. So multiplied by 10, we get 112. Where are we on our scale? Look, check it out, check it out, check it out, check it out, check it out. Well, on our scale, we are above a siren. Okay, that's a... And we are below a rock concert. We're closer to the rock concert than the siren. So we're pretty loud. Okay, we're here. We're loud, people. That is 2 watts at 1 meter. 2 watts at 1 meter. Yeah, so how do you feel about your 500 watts now? Pretty good. What if we used all 500 watts? What if we did? Where would we be if we used all 500 watts? Well, let's go back up here. Put 500 in. You know, got to get your money's worth at your 500 watt stereo, right? So let's see where we'd be. Yeah, I'm cranking it, man. I'm cranking it about more than one. Okay, let's see what we got. All right, let's go 500 divided by 3.14. Enter. Divided by 4. Enter. Divided by 1 second function exponent negative 12. Enter. 3.98 times 10 to the 13th. Now I'm going to logify that. Okay, log, second function answer, 136, or 30, well, I'm doing the multiply by 10. 13.6 multiplied by 10 is 136. So if you used all 500 watts, you'd be close to the sound of a jet. Yeah, that's what I'm talking about. That's what I'm talking about. But think about that. Now this is kind of cool, right? I mean, think about the logarithmic values. This is 2 watts. This is 500 watts. I call that diminishing returns, okay? If you ever take economics, you'll find out what that means. And what I mean by that is, if you want to get a return, you want to keep going up, you've got to start piling the watts in, okay? To get 2 watts, you can go way up to here, but 500, you use all 500, you only get up to this, you know, this amount of higher. So you have to really pile the watts in to start creeping up on that scale, because that scale, logarithmic, is difficult to move up on. You have to go 10 times the intensity, 10 times the intensity, 10 times the intensity. Okay, so 500 watts, a waste. I mean, if you use 2 watts, you'd be here. You'd be cranking that up in your house. Your parents are going to yell at you. Turn down that noise. Okay? Yeah, you're way above what parents are going to like. Okay? Sometimes, except for me, I'd be like rocking. I'd be like, heavy metal, baby, crank it, crank it, crank it. For those about to rock, we salute you. Remember, AC/DC. Okay? All right. So now, 2 watts. 500 watts. Okay, you've wasted your money. So in terms, I would think so. Maybe you don't think so. Fine, go ahead, buy your 500 watt stereo. Okay, whatever. Whatever. All right, so now let's see what would happen if, now, these videos, I got to keep these videos short. I know it's going to disappoint you, right? I got to keep them short because my phone just dies on me and it kills. I made the last video, went to 15 minutes, it's got dead and it just goes away. So I lose the whole freaking thing. So we'll stop this calculation here on this video now. So we got our 2 watts and our 500 watts in our stereo. Next time we're going to come back, we're going to do a problem. Our next problem is, what if I wanted to get the rock concert experience of 120 decibels, you know? Rock concert, baby. If I wanted that, how many watts in my stereo would I use? Okay, let's check that out in the next video.